So today's entry ticket goes over number 4, or the last two problems, I guess, on the test. Something that we struggled with a little bit, and the most important part, I did not see a lot of sketches on most people's test work. And making that sketch, you got to have the 7,500 newtons, the 8,100 newtons, and they're 50 degrees away from each other. Actually, clockwise versus counterclockwise really doesn't matter for the sketch necessarily. If you flip those around, you just would flip the picture upside down. You would still get the exact same answer. So after you do that, what you don't know in the resulting parallelogram of the forces is that 14,141. We're going to talk about that in the first part. Uh, and that is opposite 130 degrees. The reason you get the 130 degrees there, any parallelogram, the consecutive angles add up to 180. 180 minus 50 is 130. That's what we call supplementary. So once you have that 130 degrees, you can set up loss cosines. You do not know the resulting force. You know it's something bigger than 80, 100, 7,500 because those two tractors are pulling in a relatively similar direction. Their force is going to, they're not working against each other. The force is going to be bigger. So you don't know that orange line in the parallelogram, but you know it's opposite 130. And you know the side lengths of 80, 100, and 7,500 are adjacent to that 130 degrees. That's why it's law of cosines. So you throw in the 7,500, the 8,100 as the A and B in your angle. Where they come together, where they're adjacent, is 130 degrees. You cancel out a square by square rooting. You get 14,141 newtons if you round to the nearest newton, which rounding counts. It counts. Okay. The second part, what is the angle of the tractor as it's pulled towards the force of the 8,100 newtons? And that should be a smaller angle. If the force is stronger, whatever it's pulling, in this case another tractor, it's going to be pulled at an angle, a smaller angle towards that one. It's going to be pulled towards that one more. So the idea here is we don't know the angle opposite 7,500, but that is adjacent to the 8,100. That is the angle we're finding. So we set up angle A is opposite 7,500, so that's our first ratio in law of sine, sine of the angle we're trying to find. That it's opposite 7,500 because that's going to be the smaller angle. The angle opposite 8,100 is going to be the bigger angle, and it is proportional to sine of 130 over 14,141. Use the on-rounded answer from part A there to limit your rounding error. Although I think I because I let you round to the nearest degree, it doesn't actually matter in this situation. But if you use the on-rounded number, that's why we have the approximate sign. You cross multiply and inverse sine that, you'll get about 23.97 degrees, which rounds to 24 degrees to the tractor with the force of 8,100 newtons. 50 minus that gives you the approximate 26 degrees. That would be the other resulting angle. If you did sine of B, I guess, for the other angle over 8,100, and you did the exact same process, you should also get that 26.03. Those two answers make a ton of sense because they add up to the 50 degrees. That is the original angle between the tractors as they begin pulling. Please use this to recreate a problem. You'll need two forces, an angle, and then make sure you sketch the resulting parallelogram to get some points back on your Unit 8 test grade.